Hey guys, it's Vince. Today in this video we're going to be discussing a feature in Pumotix called Dynamical Motor to Axis Assignment. Now again, it's really not too new in terms of what's available. Many pieces of software have this feature, but what we're looking at is the options that you can do with it, because again I'm getting lots of questions about different systems that are using multiple Z-axis heads, where you see the machines coming from China that have two Z-axis. This is a feature that would allow you, of course, to use actual multiple spindle heads. You can see here this feature allows to disable and enable every motor assigned to a specific axis, or for that matter several axes. Consider a situation where we need to control the machine with two heads. Each of them is moved by their own Z-axis motor. In such a case, it is possible to modify M6 macros so previous tool was returned to save Z on tool change and any active motors switch performed. And again, we can break this all down. You can see they even give you an M6 macro example. So just to be very clear, I'm on Pumotix site. I'm under Dynamical Motor to Axis Assignment. And you can see how intuitive this is. They even give you the download M6 macro example right here. So if you wanted to link this, if you wanted to actually download this to your system to test it out, you could do that. It says here, when work with the second tool is finished, we can switch to the first head by the M6T1 command, which calls to switch motors 1-0 function. Machine position on Z-axis will automatically restore to value it had when the first motor was active. To control disabling, enabling every motor separately, motor disable and motor enable functions can be used which accept one parameter, motor index. And then it says to make full use of the option. It covers in detail how you guys can use this option. Again, purchase the activate option, apply license in Pumotix. How do I apply the license? You can see you can link here. Set up multiple motors on one axis. More about this setup. This function can be applied to any number of axes. So if you have a slave axis, this will naturally take into account you having a slave axis, because again you can slave as many motors as required to a specific axis or individual axis. Modify or write a new macro, use the macro to switch between motors. You can use the line for entering the G code, a button on the macro panel, or a specialized interface to do this. Monitor the system status in the diagnostic tab where you can see all the motors you have configured. Once again, when you've got the diagnostic tab, and one thing I really love about the user's manual, if you click on any images, it's going to blow it up. So you can see exactly what you're working with. Again, you can see here on the diagnostic tab when we come over axis, and I've covered this in previous videos, motor disabled, home pin, limit low, limit middle, limit high, step pin, direction pin, enable pin. All these LEDs will become active depending upon what you're actually using. I love the step and direction pin because once you actually give a command to the motors, you'll be able to visually see diagnostically what's going on, where the step and direction is actually coming from, what motor, and if you are experiencing issues, you can troubleshoot the problem very quickly with this analyzation. It makes things very, very quick. So now what we're going to do is I backed out and I went to the other image, and you can see here map to axis, and you see how again, this is very, very logical. You've got, in this case, two x-axis and two z-axis, and all they did was select the two axis they want to work with, and the step pin and the direction pin, and then over here, step pin and direction pin. Now, typically, the step pin would be different than the direction pin. In this allocation, it is not. Okay, I believe that's just for the example, but typically you would see like pin 41, pin 42 for this x-axis. That'd be correct. And then, excuse me, what we have over here with the z-axis, you've got pin 44, pin 45 on this z, and the secondary z, you've got pin 47, pin 48. Once again, step pin and direction pin are both allocated different pin numbers. The other thing I want to point out that I haven't discussed previously is that you notice that your step pin, you can invert the signal there, and you can also invert the signal on your direction pin. That is something you don't typically see in motion control software. You can invert one signal only. You're not typically going to be able to invert both or do them individually, so to speak. So again, lots and lots of different features. And then as we back out again, let's see. We'll come over here and it says also a button will become available to turn on all configured motors on the diagnostic tab when the option is active. So you can click this, you can see here, you can expand anything with a plus symbol, and then you'd be able to once again actually see in detail these feature sets. And what that's important to do is that, again, you'd be able to expand them, and you can see when it's actually expanded, you can see how your feature set for each motor is there. Of course, you can do motor allocation as well. So when I say motor allocation, you can see it says x-axis, but you can also type in your own actual feature set there. So to make this tutorial really complete, what I want to do is show you exactly what we're looking at, and I'll go over that in a second. I'm going to come over here where it says set up multiple motors on one axis, and I'm just going to click more about motor setup. You can see how, once again, this is a logical explanation. We click on it, it's going to bring us over to it. And now you can see motors. The concept motor includes such concepts as step, direction, enable outputs, home, zero sensors, excuse me, access boundary sensors, as well as the axis to which the motor is attached. Adding a new motor and setting parameters is called out on the motors. Pumotix allows you to configure the following motor parameters. Main parameters, motor name, mapped axis, step output, direction output. Number 2, additional parameters, enable output, home input, limit low input, limit middle input, limit high input. These are really cool advanced features. Typically we don't see those 3 options. Get the answer you're looking for, and sometimes, again, if you are confused by the answer you're given, you just message us and we'll get back to you as soon as possible. But overall, everything here is broken down very, very simple. You can see here again, we've got this right here as far as motor allocation, and you can see what's being done here. Once again, we got X, Y, Z, A, C, and they're breaking it all down. Now you can see your home signals. If you had home switches, additional signals, you'll see all this as you set everything up. Once again, that's totally up to you to define. And again, it's completely arbitrary to each end user's preference and system choice. Overall, though, with soft limits, I see no need for that unless you really want to get into detail with using a physical switch. But again, you have that option. So again, looking at this, it breaks everything down in main parameters, and this is what I love. It breaks all the definition down. You can see motor, the machine operator can set any intuitive name for the custom motor. By default, this parameter has a value. Motor ID equals N, and this goes through, and usually you'll see these have changed because they've updated the software. So your motor names here are usually like motor 0, motor 1, but it's completely arbitrary. You can go in there and select and type in whatever motor name you'd like, 600 ounce, 300 ounce, slave motor, master Y motor. Mapped axis. Motors can be attached to an axis. All motors assigned to the axis will carry out movements with the same parameters of steps per unit, speed and acceleration specified on the axis tab. For more information about homing, see the axis setup section. Again, step output, direction output. You can go down the whole list of how this is all broken down. Okay, but what I want to do now is come in, and I know one of the biggest questions I'll get asked is how do I slave an axis? Now we know how it's done in Mach 3. This is really logical. We go, once again, we make sure our module is off. We're going to come over here to configuration. We're going to go to settings. You can see here where it says motors. We're going to click on it. And you can see I've already set up slave Y-axis motor. And when I say set up, all you do is click on it. And I recommend anybody doing this to actually allocate the name, slave Y-axis motor, whatever name you want to actually categorize this motor as your slave. In this particular instance, if you were dealing with a G540, it would be mapped, once again, to the additional axis. And with the G540, you would not use the A axis. And I left this here on purpose. What you would do is map this to the Y. Now, what's going to allocate this to the A axis on the drive is how you allocate the step pin and the direction pin. You can see, once again, I'm in simulator mode up here because I don't have the PLCM connected. However, you can see here what we have. We have sim pin 8, sim pin 9. These are the step and direction pins to allocate the A axis on the G540, which again, we are allocating the step and direction pins to control the A axis on the G540. However, we are mapping the axis to the Y. And when we do that, that will become our slave Y-axis motor. And you can see here motor 1 for our Y-axis. So again, the master Y-axis, if I want to put that in, master Y. Okay. And you can see master Y-axis, slave Y-axis, and again, you're basically all set here as far as allocating everything in a logical perspective. So you can see here when we have the master, The sim pin is 4 and the sim pin is 5. Step pin 4, direction pin 5. For the slave motor, it's step pin 8 and direction pin 9. So you can see we've got all of our allocated step and direction pins to the motor correlation that we're working with for the axis on the G540, and in which case you now have a slave configuration set up. So now what we're going to do is we come over here and go apply. Okay, and why it's saying this is because, again, warning for correct operation required that only one function is defined to each output. Device pins used for multiple functions, sim pin 10, sim pin 11, and sim pin 12. Okay, and this is coming over here. If we click on this, the additional signals, you can see that this is on. I'm just doing this arbitrarily. Disregard that. If you do get that message, go over your actual pins, because, again, it's letting you know that it's defining. You've already set similar pins for the same actual settings, meaning you've got a home setting here and a limit low setting, and both are using the same pin numbers. So that's what that error message means. And once again, you may see that, and the software once again is alerting you and saying, hey, pay attention to this, because technically you're only supposed to have one pin allocated to actually one setting. So if you've got a home switch, you would have that allocated to a certain pin. If you have a limit low switch, it would be allocated to a certain pin. So we'll come over here, we'll go OK, and it's going to define that again. And then we're going to come over here to configuration. We'll go back into settings. And we're going to go to axis. And now you can see when we come over here to Y, master Y, you can see that whatever we typed is right there. Okay. And then you can go to your slave Y and your master Y. And now we can go set steps per unit for motor. Now this is super interesting to be able to do for whatever motor you're working with. So if you wanted to get a different step calculator done for a specific motor, you would be able to do that. Now that's only under certain instances. Now do not forget that this software does have a calibration setting for a slave configuration. It's the only software on the market that does that. So before you mess with this, I would certainly go through and do the calibration setting for your slave configuration on your Y-axis, and then you can do fine-tuning with this as well. But once again, you can see we've got the master and we've got the slave. So you can see additional features. That allows you to adjust each of these features for each individual motor. Okay? Motor is roll gang. I've had questions on this, just to show you what this does. This, once again, all features, number of step pulse signals for turning the roller by 1 degree. Come over here, the outer diameter of the roller, constant value. These are more towards rotary axis, so just so you know, once again, like all features in Pumotix, just leave the mouse over it, it'll explain it. Check this option, select the motor controls, let's see, go back. Controls the drive roller. The speed of rotation of drive rollers will automatically be calculated when the pipe diameter changes. Very cool feature for those of you dealing with a rotary axis, and typically those guys will be dealing with it with a plasma system. So again, not something you typically see on a mill. But again, you can see how this is all broken down. Once we come over here again, and this is for doing your actual motor tuning. Axis X, you can see there's no other motor. You can see Z, no other motor, V1. So you can see here how logical this is. You also have your axis visibility tab. Show this axis on the main window. If you only have 4 axes, you can remove the others. Now again, I'm using the software that's unlocked, so I have every option. You can also see, you can adjust your spindle. Okay? This is interesting because you don't get that in any other software. Like I said, guys, this software is in-depth. It allows fine-tuning of features you're not going to normally see. So again, it's got a lot of potential. You have to go through and figure out what you're actually doing. But overall, it's very logical in comparison to what we're used to dealing with. So again, you can see here how this is all set up. And once again, if I cancel out of here and I go over here and I show you guys calibration wizard, and I'm going to go to gantry alignment, and this is the calibration for your slave axis. Help for stage 1 will be posted here. And you can see distance, gantry width, and then gantry to align. And if you were to start this, you would go through and you'd be set. Once again, I don't have the software on, so you don't see that. But very powerful feature. And again, for those guys that are always worried about squaring up their axis, which I hear all the time, this is going to keep you guys true. Okay, so now you know how to slave an axis. It's very, very quick. And we also know that we can come over here and use the user's manual intuitively. You can see I have one window open for the user's manual, and then I come over here and I can go right into Pumotix. You can also come over here to Pumotix, once again, I've discussed this before, and click on the user's manual option, and you'll be all set. So again, I hope that this video has been helpful. I hope that it's answered some more of your questions. I know that many or more are going to arise. The main thing is keep them coming. If you guys do have questions, require quotes, or again, require consultations, please message me direct at storm2313@gmail.com. You can also contact me through my eDealer Direct store on eBay. I'll have links in both the beginning of the video and also at the end. Keep in mind that I am the U.S. distributor for Pumotix, the only U.S. distributor for Pumotix. So if you guys are interested, please reach out to me. If you reach out to Pumotix in Russia, they're going to send you back to me anyways. So I'm just letting you guys know. I've had that happen a couple times. I'm just letting you guys know how this is all been worked out. So again, the big thing here is that you guys understand just how powerful these features are. I'm going to be covering them more in depth as we go on. It will take some time, but I hope this video has helped. Thank you all for your support. Take care.